So my name is Eric Fung. I work at a company called Shopify out of their Toronto office in Canada. This talk is called Playing with Firebase. Despite sort of the phrase, playing with fire connotes danger, getting hurt. It's really just a pun. None of my colleagues or I were injured in playing with Firebase. Shopify is a commerce platform to help small and medium businesses run their stores across multiple channels. We also are trying to get people to come and build their stores on our platform. So we publish a couple different blogs with original content about how to become an entrepreneur, how to take product photography. And so recently I worked on an app for Android that lets people read our articles. So we call it Entrepreneur's Digest. It's a pretty basic full screen kind of reading experience. It lets you browse all 1,200 of our articles. And I had the luxury of just being able to choose the tech libraries and stack I wanted to use this time. And so it's like, this is great. I can give Firebase a try. So if you haven't seen sort of what the full Firebase platform is, it's much more than a real-time database. Since Google acquired the company, they've slowly been moving a lot of their services under this Firebase umbrella. So now, in addition to real-time database in the top left corner, you have a whole suite of tools to use during your development, when your app is launched, to grow it, to earn money. And the diagram is all sort of this ring circled around analytics, because that sort of ties everything together. Or, in another sense, all of these different features feed analytics into the central system. Besides these client SDKs on iOS and Android, there is a console for you to fiddle with settings and to also monitor what's going on. This talk, I can't obviously cover all 15 of those services. I'm going to focus on 4 of the ones that I used when building this app, and hopefully it'll give you ideas for how you can use it to start investigating Firebase. I'll touch on app indexing, dynamic links, remote config, and cloud messaging. And because analytics is at the center of everything, I'll mention analytics also. Hopefully it'll give you ideas, and you'll learn from some of the mistakes I made, and you'll perhaps share in the shortcomings that I've experienced when using Firebase. I'll provide a bunch of links at the end so you can get more information and to find out what's happening in the world of Firebase. What I won't cover is how to do sort of the basic setup for all these things. The Google documentation really has step-by-step, and there's a ton of samples, but I will sort of, at a high level, go through those. First off, I want to just give a quick tour of this app so you have some context about what app I was building and how Firebase played into that. So even before you download the app, this is a mobile web view of our blog. We have a little banner at the top that when you click on it, it takes you to the Play Store to install the app. Once the app is installed, the first launch, you get this sort of overview of, again, an overview of all these articles. When you click on them, you get a full screen view to read it. Those articles are fetched in the background to keep it up to date. So if you haven't come to the app in a while, you'll always pull down the summaries of the latest articles. When we publish a new article, we send out a notification. That eventually triggers a actual notification to show up in the UI that you can tap to get back into the app to read the article. We have done the app indexing so that when you search for terms in Google search from either the Google bar or the Chrome browser, you'll see the search results with your app icon there, and that'll take you back into the app from search. And related to that is anything that you viewed in the app shows up as a suggestion for search autocomplete. So let's start looking through some of the Firebase features that enable this. This first one I'll talk about is app indexing. So what is it? It's a way to get your app into Google search results and a way to associate your app with your website. Now, for a blog app like this or a news app or anything where you have content that is on your website that you also are making a native view for, certainly consider app indexing. It's a very natural thing to include for those kinds of apps. What does it give you? The documentation says install cards, but I just searched like this live wallpaper I made 3 years ago. I searched for it. from the mobile browser, and I get an install card too, and app indexing didn't even exist back then. So I'm not sure that you really need app indexing to get an install card. But if you're not getting an install card for your app from mobile search results and you want one, you might try implementing app indexing. Why is this important? Google did a marketing or research study. It says 1 in 4 apps is discovered through search and not by people just kind of poking around in the Play Store or seeing ads. They're searching for keywords, searching for the name of your company or something like that. So that's a way to surface your app outside of the Play Store or the App Store. It also lets you deep link into your app from search results. So here I'm just typing some keywords and the results come up, and when you click on them, they go right back into your app. So this helps with something called engagement, where users already have your app and you want them to come back and use it. A lot of people, something like 1/4 of all apps that people have installed on their phone aren't actually used. So this is a way for you to get people to come back into your app. You might have something like a search ad, a certain kind of banner ad that comes up when somebody is searching for something, and you can put a link back to your app content that is related to whatever they were searching for, rather than just installing the app or going to the front page of your app. And the last thing, which I showed earlier in the feature tour, is that you can index actions that people are taking inside your app. So if they view a video or they listen to some music or they view an article, that's actually a piece of structured data that you can tell Google about that they did this action, and then it surfaces as a result in the search. And then when you click on it, they'll come back to that article. So it's a way for them to track their history. So to do app indexing in your own app, the first thing you need to do is to understand the URL structure of your app. So this is an example from our blog. The very first URL there is an actual page from a particular, well, it's not an actual page, but it's like that's the URL structure of our articles. It could be some sort of freeform slug in the last path element there. We also have topic pages, so every article could be about entrepreneurship, it could be about whatever, Facebook marketing, and they're all tagged with topics, and the last link style is where you would go to see all articles with that. So the things you're looking for when you're understanding your URL is set of URLs is whether it uses HTTP or HTTPS, or you handle both. What domains, maybe for SEO purposes. We host our blog on, or make available our blog on a whole bunch of different top-level country domains. What kind of paths are being used? So you see everything here starts with /blog, but some of the pages are a little bit deeper in that hierarchy. And when you're designing your app to sort of display all your app content, you probably are going to match an activity to each type of link there. So that's something you're going to think about too. We'll get back to that issue of where everything kind of comes off of /blog and how to handle that. So just keep that in mind. I have a little fire icon next to that. It's an area where it caused a bit of a problem. So I'm just going to call that out. So I've used 2 kinds of emoji there. A fire one means this is somewhere where I had trouble, and the firework one, which is exciting, is somewhere where it's a tip that will help save you time or avoid making the same mistake that I did. So the issue is that you might not be able to map a particular activity to the same URL structure, like have a one-to-one mapping of that. And so we'll talk about that in a bit. So the next thing you need to do is to tell Google that your website on this domain is associated with this particular app. On Android 6 and up, on Marshmallow and higher, this is really easy to do. There's a specification called digital asset links, which Google worked on. It's basically a file that you upload to your web server at a well-known location, actually called well-known. And that file has information about the package name of your app, so whether it's the bundle identifier in iOS or your package name in Android, and a fingerprint from the certificate that you use to sign the production app with. So you need to put this on all the different domains that you are going to support. So again, back at my example, we have .com, .ca, .co.uk, whatever it is. This is what it looks like. It's a little bit small, but it's just a JSON file. It's an array. It's got the package name from our app, and the namespace is called Android app, and then the certificate fingerprint. It's an array at the top level because you could declare multiple apps in one file if you have multiple. If your website's really big and you have multiple apps to handle things. Now you could ask, oh, my users, I'm still supporting, SDK 19 or something like that. What do I do then? So it's a little bit more work, but it's also doable. Here, instead of just putting that file on your web server, you need to use the Google Webmaster Search Console. There's a lot of steps, and they have a lot of documentation about this, but the key ones are, you first have to add your Android app. You declare that I have this app that is going to be associated with my website. And you need to link your web pages by putting some HTML markup on page. And then once you've done that, you can get Google to, when it next crawls your site, you either trigger it or wait for the Google bot to come. It'll see that, and then you'll see the results that they're indexed. This is the markup that I just mentioned, what it looks like. And so if you have a page that's hosted at /blog, that slug there, you just put this in your head. It's a link, and the href has a specific format with the scheme of Android app, the package name of your app, and then the path where that it relates back to. So this linkage is something I didn't know about when I first implemented it, and I just, I was testing this app on an older version of Android, and it just wasn't really working. It worked on some devices, but on others. And so what's the behavior if you don't have this linking? Well, you get the dreaded chooser dialog. So it just pops up and says, oh, do you want to open this URL with a browser, with another browser, or with your app? So that is obviously not the experience you want your users to see. If you spend all the time crafting a native app, you want the users to be linked directly to that. So that's something I have to go back and get our front-end developers to help me set that up. So let's turn to what you have to do in your app. You need to look in your Android manifest at your intent filters. Here's where you're going to declare that in that activity, this activity, I want you to launch this activity when somebody clicks on this URL. And this data element specifies the details of what paths that you're going to handle. So you see there's some attributes like scheme, host, and path. So this is saying that this activity, where this intent filter lives, is going to handle the URL https www.example.com/recipes. And you may have different activities for different URLs, and you declare them all in your manifest. In this example here, this is going to match exactly one page called /recipes. It's an extra space there. Because it's the attribute there is called path. If you've used intent filters with URIs before, there's other attributes. One's called path prefix. As that implies, it would match anything that just starts with /recipes. There's also one called path pattern. But before you get too excited, it's not a regex. It's kind of like DOS wildcard. It's just .* or not even a question mark for 0 or 1. And that has to match the entire pattern. In addition, there's no support for things like exceptions. So you can't say, well, I want to handle all URLs that are in /recipes except /recipes/ deprecated or old or something like that. You can't. Once you declare a prefix or pattern, it matches everything that just matches naively like that. Now, recall that I said, our blog is hosted on like a dozen different top-level domains, and it's available on both HTTP and HTTPS. Having to list all the combinations, even if I'm saying that all my blog articles are under /blog, would get tedious. But it turns out that the way that intent filters build up those data elements, you don't have to specify each URL on each domain, on each scheme that you have. Every one of these data elements contributes to that same intent filter. To borrow a math term, it's like taking the cross product of all of these, the combination of all of these things. And so that will definitely save the amount of work you have to do. So at first, what I was doing was I had some little script that would know about all the domains, know about all the patterns, and then just generate those data elements. But then I realized, I don't have to do that. I just need to specify each component in that filter, and it will all match. Okay, so now we've defined a filter on our activity. So now that once this app is installed, Android will know that it declares that it's going to handle URLs. So when you click on those URLs, you'll get taken to your app. And before I move on, remember that I said that there's a bit of a problem if you have things that have the same prefix. So here I'll have all my articles are under /blog / some arbitrary slug. Whoever's creating that content It's going to publish it with whatever SEO-friendly slug. But I also have a bunch of pages under blog topics. So I can't declare a filter that matches topics, that matches all the articles. So I have to use path prefix because I don't know what the pattern is. But that will also match topics. Now, it's not going to be the same activity in my case that handles the articles as well as those topic pages. So how do you handle that? The way I came up with is to use what I call like a router activity. So you just declare a single activity that handles everything under /blog, and in its onCreate, when Android launches it and passes the URL, you'll get back in the intent, in the data element, in the getter there, you get the URI, and here is where you can use Java's regex and pattern matchers or do some sort of other sophisticated logic to decide which activities to launch for that URL that was passed to you. Okay, so the last thing about app indexing I want to talk about is that search autocomplete, which is indexing your user actions. So remember that this, this shows up as that if somebody's viewed an article and they go back to the Google search bar and search for some keywords, Google actually prompts them and says, oh, you looked at this article, come back to it right away. So up to this point, we haven't had to do any sort of dependency from a Firebase library. Intent filters, adding stuff to your web server, putting markup in is all stuff on the website or in your manifest. But here, to use this API, you need to include the app indexing library dependency in your build.gradle. This is not a typo. You do actually create something called a thing. And it took me a while to figure out what that meant, but it's actually from, if you're aware of structured data in schema.org, the top level root thing is called a thing. And so there's things like, keep using thing. There's pages, there's music, there's any sort of thing, anything that can appear on the web, the structure, the top level thing is called a thing and has attributes that are common to all resources on the web. So it could be the title or the name. So you create a thing that's of type, I think, web page. And the action in this case is the user viewing it. So there's an attribute called type view. So you create this, you put the thing inside the action, and then in the app index API, you call start when the user starts to look at the article, when they tap on it. And then when they leave the article, you call stop. And that creates some sort of metadata that is sent up to Google. And that will start showing up in the autocomplete. I mentioned also briefly that it shows up in the history. So if you go to history.google.com while you're signed into your Google account, Google, unless you've opted out, Google shows everything that you've ever done on your Android device, on your browser, including at the top you see, I viewed this article. And that entry comes from the app opting into this or implementing this app indexing API. So that may be a consideration for you and your users, whether you want to warn them that this is going to happen, or they can also just opt out, in which case nothing will happen. Okay, so that's app indexing. The next piece I want to talk about is dynamic links. So what are they? It is a cross-platform deep linking scheme that survives app installs and drives installation from mobile web users. Let's break that down a bit. Survives, what does that mean? It means that even if the user doesn't have your app, if you want to deep link into a piece of content, a dynamic link will allow them to install the app and then continue right into that content. This is super powerful because you would not normally have another way to do this. You could put an app banner like this one, and you're like, oh, this is going to take people to install the app. Well, I could just put a URL to the Play Store behind my banner, and they would do that. But this dynamic link does so much more than that because it's a single link that will either take users to the Play Store to install the app if they don't have it, or it will, if they have the app already, will deep link them right into the content. And moreover, if they didn't have the app and you get taken to the Play Store, notice that this button usually says open when you install the app for the first time, but here it actually says continue. And that's sort of a hint to the user that they're not going to go to the front page of the app. They're now going to get linked directly into the content. So imagine they're on the mobile web view of your page. You have this little banner like I had there at the top that says, download the app to continue reading this. that's literally what would happen, is after they install the app, they would be deep linked into the same article they were looking at in the mobile web view, but this time inside the app. And another bonus of this, even though this is an Android talk, that same link, without changing anything else, that same dynamic link will also do the right thing on iOS. So iOS has even more complicated URL handling rules depending on if it's iOS 9 or older. There's something about universal links. That same link will take people to the iOS store and then also either deep link into it or cause them to install the app. So it's a very powerful feature. The nice thing about these two is that they're implemented with a way to shorten them. And again, you're like, oh, well, I use Bitly or I use go.gl or j.mp or any of the other shortening things. That just gives you a short link, and they may provide click analytics, but they're not integrated with Firebase. Using the dynamic link shortening service gives you analytics not only on the click, but also what happened when the user clicked it, whether they installed it for the first time, or they were coming back, or they needed to update or upgrade the app to handle that content. Short links are also useful when you want to pass these around in SMS. So Google promotes the use of dynamic links across different media. So whether it's a web page, whether it's a physical poster, whether it's an SMS, or whatever campaigns you're using, you can use the short version of that link since they will fit nicely in any sort of character restriction. I mentioned before you get the click tracking. So this is, and from the Firebase console, this is what it looks like. You'll know how many people have clicked on your dynamic link. In my case, I wasn't deep linking into our articles. I'll mention why in a bit, just because we were showing that banner on the top of all of our mobile web views, and it would be nice to deep link right into any one of our 1,200 articles. But the technology literally didn't exist from Firebase to make that easy to do at the time that we were building this. So let's look at the first step in working with dynamic links. You go to the Firebase console. Under the dynamic link section, you open this form up. You enter all your basic details. There is a friendly name that you put so you can see it on the console. You put the URL that you want to deep link into, and then you pick the app that you want it to target. When you create link, this makes a short dynamic link, which you'll see on the console and can start looking at analytics. If you need more sophisticated links, perhaps there's a varying component, perhaps in your CMS, you want to include the current page people are viewing in that dynamic link. You can also build them using this longer form of the URL. So here, you actually construct where the pink part where it says your deep link, you put in the current page that's URL encoded, you put in your package name. This is just literally a fraction of the full set of query parameters that you can put in, because this is just showing a few of the Android items. You can also include all the iOS parameter names too. And that long link, when you click on it, will do different things depending on if you're in Android or iOS. So the big caveat with this is that you don't get any of those click analytics anymore. And this wasn't clearly documented, but I've since submitted a request and they've fixed it. You don't get any click tracking when you use the long form of the links. It only happens when you use the short form. And it's pretty cumbersome. So the way that eventually in mid-October, this past month, they released a REST API for you to turn long links into short ones. So if you've already created a bunch of these long links, you can now programmatically submit them and you get back the short link, which will show up on the console now. Or you can just build them up the same way by putting in these values and the parameters in sort of a JSON body and a request to get short links. So now you get your analytics back. Now, when you're building these, it can get complicated because a single link you can configure to do many different things depending on if the app's installed or not. What's the behavior when you click the link on Android versus typing in a short link manually, because that can do something else. What happens if people click it on a desktop browser? What's the fallback? So I don't know how long this has been around, but I just discovered this last week. When you're using sort of this long form of the programmatic URL there, the first long URL there, if you add a D onto that query parameter, it doesn't actually do whatever the behavior is if you had clicked on it. It actually just returns you this interactive flowchart. It's like a web page that it generates on the fly. It's really hard to see because it's a long diagram, but it shows what happens from your dynamic link when people click on it in Android, which is in the light green there, or on iOS or on desktop. And these little branches here, it says, so if they click the URL, they follow this path. If they're typing it in a browser, It says it's going to take them to the Play Store. If they have Play Services 8.1.15, then it goes down here. If it's less than that, it'll go to the Play Store. If they don't have Play Services, what happens? Is the app installed? No, it takes them to the Play Store. Is the app installed? Yes. Is the app version greater than a certain version? Take them to Deep Link, or else do this. And the same kind of branching for iOS. There's questions about whether it's iOS 9 or higher, whether the app is installed, whether you support universal links or not. So this is just a visual kind of display of the power of the dynamic links, is that single URL can handle all these different cases for you. The final caveat I want to mention is that you can't delete dynamic links. For whatever reason, it was either an oversight on Google's part. They recognize and they've acknowledged that this is a flaw or a weakness, and they're going to fix this at some point. But if you're doing testing, those dynamic links that you're creating, the short ones, they're just stuck in your console. On the Android side, so all this dynamic links, you can create them, you can use them if you've implemented app indexing, like in the previous section. You click on them, and you'll go right into your app content. And so at the beginning, I didn't know why I would need to do anything else, because everything was working. I would click on the dynamic link, would go to the Play Store, would deep link to my content. It was working really well. But I wasn't seeing these analytic events. And it turns out that you need to consume the link that's launched into your app. And so the confusing thing also is that...
It's 3 o'clock.
Thank you. Just told me the time in German. It's called Firebase Invites, which is a library dependency. Now, there is another Firebase service called App Invites, which is built on top of dynamic links and allows you to send custom invitations to people when they first install it. They can see a message from you. But it didn't make sense to me why I'm using the lower level dynamic links. I had to include the dependency, but it's just all rolled into the one dependency called Firebase Invites. So you have to include that in your app. And in every activity that could be launched from one of your URLs, you need to call this get invitation method. They call it consuming the invitation, clearing it so that the click tracking will work. Which activities you need to consume it on is any activity that you declared in your manifest as handling these URLs, plus your launch activity, if that's not the same activity as the one that's handling it. This is because if your app it wasn't there before and it was just installed, Android will launch your main activity first before passing you the deep link for you to jump to. If it was already installed, it would go to whichever one was declared to handle it. So those analytic events that you're getting when you consume the event are these three. The first one is generated when the app is installed for the first time from a dynamic link. So this could be when you're looking at your analytics, a conversion event. You want to know how many people are downloading the app as a result of this campaign that you included the dynamic link in. The second one is any time the user has come back to the app as a result of clicking on it. So again, it could be you're using the dynamic link in a search ad for a particular piece of content, and they click on it and they come back to the app as a result of that. So you can filter on that event. And the last one is if there's some new functionality and they had the old version of the app and they clicked on it and the dynamic link was configured to upgrade them first, you would get that event. So again, if you don't do this, your deep linking will still work, you just won't get those free analytic events that you can monitor on the console. All right, so the next topic I want to quickly run through is cloud messaging. You've probably heard of this Firebase, you've probably heard of cloud messaging before. It used to be called GCM, and before that, C2DM. It's just the same Google Cloud Messaging under the Firebase umbrella. It's a cross-platform messaging service for reliable delivery of messages. The key points about FCM is, if you ever tried to do any sort of mobile messaging, is that it handles all the hard stuff for you. So keeping that connection alive in a battery-efficient way, determining if the user's connected or not, respecting the user's the battery or whatever preference they've set about when to send these messages. It's all taken care of for you at scale. So huge chat, social networks or things, they all rely on cloud messaging to be able to deliver these messages quickly. The other thing you get is, out of the box, is just displaying that notification. So we're about to pull down the scroll here, and you can see notification generated. So if you've ever used GCM in the past, you still had to do a bunch of stuff yourself. You had to register for the service and send up the token. When you got the message, you had to go create your notification. Out of the box, the UI is all done for you. All you have to do is declare, I have a title, I have a message. It takes care of receiving that message in the background, creating that notification, posting it to the notification manager, and then also setting up the click so that when you tap on it, it goes to your app. So if you ever struggled with doing notifications before, out of the box, the Cloud Messaging library gets you that for you. Now, if you look carefully at that slide with all the Firebase services, you might have seen something called notifications, which sounds really similar. So I just want to have a quick diversion to talk about how Cloud Messaging differs from notifications. So notifications is built on top of Cloud Messaging. It's a brand new growth tool that is basically a console feature in the Firebase console that allows non-coders to be able to send messages. So it's got this nice UI where you can kind of click and choose options like only send this during a certain time of day. So, don't send a message in my users, when they're sleeping in their time zone. So it can do scheduling like that. It can do user targeting and segmenting. So only send users who display language is set to French or something like that. Or only send to users that are experiencing this crash or in this geographic zone. It gives you a lot of built-in analytics on the open rate, so how well your notifications are performing. And it is designed for non-coders. So your growth people, your product people can use that console. Now, how do you know which one to use? Well, notifications, as I was saying, gives you these basic messages that are meant to be displayed to the user, and you get these analytics. And if that's all you need, then, and you like the targeting features it gives you, then you should stick with notifications. Include that dependency for the cloud messaging in your app, and literally you don't have to do anything else. So if you've seen the I/O demo about Firebase notifications, that's all that I think Lawrence Moroney did on stage. He included that dependency, and then the other person just sent a message from the console, and it just got to the device, showed the notification, they tapped and went. However, if you need to do anything else, you got to use cloud messaging. So anything else, what does that mean? If you want to customize the UI beyond the simple ways that the console gives you. For example, the best practice for UX of notifications is to group similar ones together, right? And the way that you need to do that is to have access to the notification builder, which you don't get because everything is kind of handled automatically for you. And also for the case where you want to send messages that you're not intending for the user to see. So push notifications can also be used to tell your app that there's new data on the server, and your app might need to do something first before it can surface that notification to your user. So you don't get that with the built-in behavior. So cloud messaging, how do you implement it for your Android app? First thing you do is you add that library dependency to your project. Then you declare a messaging service. So this, you need to subclass the service that's given to you and just declare it this way. This is all just boilerplate code. You can cut and paste it from the Google example. In that messaging service class, there's a method that you override called onMessageReceive. And this is sort of the entry point for when your notification comes in. Other stuff like registering for a unique ID so that Google servers can know how to talk to you, that's all handled as soon as you include that Gradle dependency. You don't have to deal with that. If you've done GCM before, you knew you had to worry about rotating the token if it needed to be refreshed. You don't need to worry about that here. The only thing you need to do is declare the service and implement this. And when a notification comes in, your service will be started, this method will be called, and then there's a whole bunch of different getters on the message to get the attributes that you sent yourself, either from the console or manually, which we'll see. So what you want to do here, if this is a message that's meant to be displayed, this is where you would either call another service or do it right here, is to create the notification object, post it to the notification manager, or you would schedule some sort of job to sync with your server first, and then when that's done, you can show the notification if that's what your message is for. It just touched on registration IDs. In the past, you needed to also run this app server to handle receiving these registration IDs and mapping them to your user so that if you wanted to send a message to that user, you knew how to send it to them. Because it's kind of opaque what's happening under the hood. Is it WebSockets? Is it XMPP? Is it, what kind of protocol? That's not meant to be visible to you. The only thing you have is this registration ID that the device sends you, and then you send a message to Google Service and says, I want to send a push notification to this registration ID. Google takes care of figuring out where it is right now, how to get to it. You can still do that here. If you are doing something like a chat app where you need to have one-to-one kind of messaging routed through your server, you still need to manage that. But for some cases, including mine, the publish-subscribe model was enough for me. So think again about how this blog app works. Every time there's a new article, I just want to send everybody a notification. So in the publish-subscribe model, what is called topic messaging in Firebase, you just say subscribe to topic, all new articles. You don't have to prearrange, you don't have to register these topics on the console, the Firebase console. You just say subscribe to topic. Firebase does something and sends it to the Firebase server. And when you want to send notifications to everyone subscribed to this topic, you just include the topic name in the body of the message, which we'll see in a second. So this is a handy way for you to not have to create an app server. And in my case, I don't have an app server at all running to support these notifications for new articles. Next, how do we actually send a message? So the console will let you send messages, but it turns out it's not the right kind of message, which is actually jumping ahead a bit. So I just talked about you can either do it from an application server or you can do it manually. So the payload of what a message actually looks like when you send it to the FCM server is like this. It's just a little JSON payload. It's got a data object in it. And in the data object, you can have whatever keys you want. Those just get sent to you. If you recall in the onMessage received, that remote message, we had a get data, which returns you a map of the key value pairs. Those are exactly the key value pairs that you put in the data object here. So it's completely arbitrary data. And then in the to field here, the value is that topic. And so it starts with /topics. And this is telling FCM, I want you to send it to everybody who's currently subscribed to that topic. And I said 2 slides ago about how you could do it manually. And this is literally what I do. I don't have any sort of automatic integration with our CMS of how our blog is published. So I kind of manually just send these when I know that there's a new article, which is sort of a hacky way, but it actually works for us since we publish like 1 article a day. It's not too onerous for whoever's responsible to send it. And it's as simple as this. You grab the server key from the Firebase console, and then you just pass it in the header, and you send the body from the previous slide there. I put a fire emoji here because this is something I've noticed on the Firebase mailing list that confuses a lot of people. It's a distinction that existed back in GCM, but I don't think it's clear enough that I want to highlight it here for everyone. There is a difference between there's 2 kinds of messages that you can send. So just backing up in the slide, this payload here has this data element, and that makes it a data message. The other kind of message you can send is a notification message. So they're kind of poorly named, but there's a big difference in how they're treated by the client library out of the box. This chart from the documentation, this little matrix shows you what happens when you send a notification message and what happens when you send a data message. So that free behavior you get when you send a notification message is, if it is received in the background, you'll get a notification in the system tray automatically. If you get it in the foreground, nothing happens, but your callback gets called. But with a data message, there is no default behavior. All you get is that callback. And then in the case that your message has both a notification and a data object, there's slightly different behavior there. So the notification console only sends notification messages, which means they're always displayed when they're in the background. When you want to do any sort of custom behavior or when you want to send messages that don't need to be displayed to the user, you should be using data messages, which precludes you from using the console because it can only send notification messages. I think that's all I want to say about messaging. I did a more detailed talk about cloud messaging at another Dev Fest a couple months ago, so there's way more detail about dealing with messaging if you want to learn more. The last piece I want to chat about is remote config. By the way, I didn't draw any of these. These are all from Google. but I don't work for Google. Remote config is a way to change behavior and appearance of your app without needing a client update. So perhaps a classic use for this is some sort of A/B test. You want to see if a certain color button attracts more clicks than another color. Another way that they promote using this is to just sort of tune parameters in your app. So whether it's, I don't know, delays on animations or something like that, without having to do any redeploy or publishing of your app. So there's on the left here is an example of what the remote config console looks like. Right, I said you can tune different parameters, and also you can run experiments. So in my case, there's two ways I used remote config. One is to tune sort of the timing of when the app syncs to the server. When we launched it, we didn't know how many people would use it, so perhaps the staggering of the timing of the sync was going to DOS our own servers. So I wanted to be able to have a remote way of tuning that so I can tell the clients to back off. And the other experiment that I ran was just an A/B test on the title of notifications. So when there's new articles, the subtle difference in the title is that in one variant, it's just a generic, new article message, and the other it actually included the title of the article, because that's the first part people can see when they pull down their notification bar. So remote config is not just about remote configuration values. Google's suggestion is that you use remote config as sort of the single place for putting any sort of configuration information you have. Sort of like a shared preferences, but just for sort of app config that you can populate with default values that are local to the app. And because it's a single access point, when you decide to have the tunable server features, you can also turn on fetching values from the server to update the ones. And there's a whole complicated precedence of, it first checks to see if the server has a value. If it doesn't, but does it have a default one? And then is it fetched? Is it fetched but not activated? And then it falls back to your local one. So the way you start is to just create a remote config object, which I'll show in a second. This remote config, the single class, also is the one that you will use to fetch what the server values are. It will handle caching them, so you don't have to always make the network call to get the latest values. Especially, you can tune this if you know that you're not going to be changing it all the time. If your app is mature and it's running stably, you don't have to tweak the config as you would do at the beginning. And there's also a distinction between fetching the values and turning them on. So why do you have this distinction is that, say you're in the middle of the users on some sort of onboarding experience or doing something important and you have an A/B test on the color of the button, you don't want the color of the button to change in the middle of what they were doing. That would be confusing and jarring. So you can choose exactly when to activate the values. And the way to set up the config values, as you might have guessed, is through the console. And the parameters have optional conditions, and this is what enables A/B testing. So it doesn't have to be the same value that's fetched by all clients. You can define conditions so that different devices or different audiences or different, whatever characteristic of the user, those audiences or those groups of users will get different values. So how do you get started with remote config? First thing is to include the remote config library in your build Gradle. And then start by thinking about all the places where you might want to have some kind of tunable config and list them all in a default XML file. So hopefully you can all see this. I have 3 different values in this one. It's just a simple XML key value map. I have one called sync min seconds and sync max seconds. They have a numeric value there that is used for the minimum amount of time I want to wait before I start a sync, and the maximum amount of time. And then I have something to record the value of the experiment that I'm about to demonstrate, and with a default value. So these are all defaults that will be in effect if there is no value from the server. So once you've defined this under, I think, res XML, you set them onto your remote config object like that. So simple. And then this call you would make somewhere during the startup of your app before you actually start reading from it. And then in your code, any place that you wanted to get, what is the minimum sync time, or what is the current experiment, you would use that same remote config object and just like a bundle or a parsable or shared preferences, you just call these convenience get long, get string, get boolean, and the remote config I think internally does the casting for you, and I think it'll just throw an exception if you've mismatched the type. But that's what you need to do to read from this config file. The next step is when you're ready to use tunable things from the server, you would go onto the console and define your parameters. So there's a very simple UI here to define the key and the value. Once you add it, it's not actually live yet. So you can kind of set these up when you want to roll them out. At some point, you can click publish, but don't forget, you do need to click publish before it becomes live. Now, that's all you actually need to do if you just want to have some sort of tunable config that is applicable to everybody. If you want to set up an experiment, you need to define a condition so that when remote config is fetching the value, it can decide for this user, should it be this value or some default value. So conditions are defined independently of parameters because you can reuse the conditions, but you can specify things like the user is in a random percentile. And so Firebase ensures that the user is always in a particular bucket. So if you say user is in like less than the 10% bucket, they'll always be in that bucket. Or if you say from 0 to 50, they'll be in variant A or variant B. Analytics also has a concept of audiences which you can define, so you can say users in this audience. You can have it by region and country, you can have it by language. You can define conditions on a number of different ways. Now, so here's an example of defining a condition that I'm using to do sort of a 50-50 A/B test. I really only need to define one condition, so that's user in random percentile is less than equal to 50, because the default value, if they're not in this bucket, is what will be the other bucket. But you could define a different kind of A/B test, like maybe 5% of users. So that would be user in random percentile less than 5, and then another condition would be user percentile between 5 and 10. And then everyone else would be in the default bucket. And then once you define the conditions, you assign them you attach the conditions to the parameters. So in the corner here, it says add value for condition. That's where you would get this. So once you click the add value for condition, the drop-down comes and you pick the condition. And then you tell it which value should be given to the user for that condition. And then there's also a default value at the bottom. So once that's done, back in the Android app, you would call remote config and fetch at some point when you want to get what the server values are. I haven't described it here, but there's a cache expiration. So you can say if you're changing it a lot at the beginning of your app, you might want to set a lower cache expiration because it won't fetch new values more often than that cache. So I think the default is 12 hours. And you can also set up a debug mode so that when you're testing this, it won't respect the cache. It will always hit the server. I put this in a comment here is once the fetch is successful, you can immediately activate it if what you're doing isn't going to be user visible. You're not doing a test on the color or test on the copy of something user visible. Or once it's fetched, you can note somewhere that it was successful and then activate it when it makes sense, perhaps on the next start of the app. And the last step for remote config is we want to measure something in an A/B test, right? We want to know whether users are spending more time or they bought more in-app purchases or something like that. And so we have to record somewhere what the variant that they were assigned to. And so the way to do that is to use an analytics user property. And so if you've got the analytics object around, you call set user property with some analytics property name and the value from remote config of which experiment variable. Once you have a user property, you can build an analytics audience out of that. And those audiences are used in the analytics console to break down like user engagement or break down some other event that you've recorded. So that's all about Firebase that I want to talk about. As a quick summary, we talked about app indexing to get your app into Google search results. We use that so that people, when they search for content, they can be suggested to install the app and to deep link back into the app. And to also see their previous actions in the search autocomplete. We use dynamic links to put an install banner on a mobile web version of our website that could potentially deep link into the app or trigger an install. We work across platforms. We use cloud messaging to both send a message that should be visible to the user and also to send now is a good time to sync, I have new data for you type of message. And we use remote config to do some simple A/B tests and also to tune some sort of timing parameters. I'll make the slides available soon after this, but there's a bunch of, the first link in all these here is the docs from Google, just in one handy place for you. But there's a bunch of other articles that are useful from other people's implementation experiences that might be useful. Finally, if you've done Android development for any amount of time, you know that there is a lot of information published by Google all over the place. And many of these places you don't know until you sort of accidentally run into it. Like, you know that Google has a whole authorship on Medium. People publish on Medium. Employees have personal blogs. Employees publish on Google Plus still. There are YouTube channels, more than one. Some places, if you're interested in Firebase, to keep an eye on. This is very time sensitive because it's happening November 7th, which is Monday? It's Monday? In Berlin, so keep in mind the time difference. They are live streaming the whole event, but this is all of the Firebase team going to Berlin to sort of give a state of the union about what's going on in Firebase and hopefully what's coming up in Firebase. There is a status dashboard. If something isn't working, despite the best of your ability debugging, check the dashboard to see if perhaps cloud messaging or something has an outage, which occasionally happens. Google and Firebase employees hang out in both the Slack and the Google group forums. There's also a blog where they publish Firebase-specific things at, something called Firecasts, which is just Firebase stuff in a sort of screencast format. That's all been merged into this YouTube channel now. One thing you want to keep an eye on to keep up to date with the latest features, and they're working on them constantly, is this changelog for the SDK. And then to get you started really quickly, in this repository on GitHub, every one of those 15 features has a sample app. So you can go check that out. I only have 5 minutes and there's another speaker, so I don't know if I'll have time for questions, but I'll certainly be happy to chat with you about Firebase, about what Shopify does, and if you have anything else you want to chat with me about. But thanks for listening.